In this video, I am going to talk about wireless client authentication methods. You can use many different methods to authenticate wireless clients as they try to associate with the network. The methods have been introduced over time and have evolved as security weaknesses have been exposed and wireless hardware has advanced. This video covers the most common authentication methods you might encounter. First, let me to explain about the open authentication. The original 802.11 standard offered only two choices to authenticate a client: open authentication and WEP or WEP. In this video, first I'm going to explain about the open authentication. After that, we can talk about the WEP or WEP. About the open authentication, actually open authentication is true to its name. It offers open access to a WLAN. The only requirement is that a client must use an 802.11 authentication request before it attempts to associate with an AP. No other credentials are needed. When would you want to use open authentication? After all, it does not sound very secure because it is not. With no challenge, any 802.11 client may authenticate to access the network. That is in fact the whole purpose of open authentication, to validate that a client is a valid 802.11 device by authenticating the wireless hardware and the protocol. Authenticating the user's identity is handled as a true security process through other means. You have probably seen a WLAN with open authentication when you have visited a public location. If any client screening is used at all, it comes in the form of web authentication. A client can associate right away, but must open a web browser to see and accept the terms for use and enter basic credential. From that point, network access is opened up for the client. Most client operating systems flag such network to warn you that your wireless data will not be secured in any way if you join. This figure shows an open WLAN discovered on a Windows-based client. Notice the shielded shaped caution icon and the security type unsecured. Actually, in this method we don't have client authentication, only we have user authentication. It means that the client device can join to the network without any authentication, but after that the user should enter the username and password as a credential for joining to the network. The next method is wired equivalent privacy or WEP or WEP. As you might expect, open authentication offers nothing that can obscure or encrypt the data being sent between a client and an AP. As an alternative, the 802.11 standard has traditionally defined wired equivalent privacy or WEP as a method to make a wireless link more like or equivalent to a wired connection. WEP uses the RC4 cipher algorithm to make every wireless data frame private and hidden from eavesdroppers. The same algorithms encrypts data at the center and decrypts it at the receiver. The algorithm uses a string of bits as a key, commonly called a WEP key, to drive other encryption keys, one per wireless frame. As long as the sender and receiver have an identical key, one can decrypt what the other encrypts. You can configure up to 4 WEP keys to be used on a WLAN, although only one of them can be active. The key number is included in the wireless frame so that the sender and receiver can know which one of the 4 to use. WEP is known as a shared key security method. The same key must be shared between the sender and receiver ahead of time, so that each can derive other mutually agreeable encryption keys. In fact, every potential client and AP must share the same key ahead of time so that any client can associate with the AP. The WEP key can also be used as an optional authentication method as well as an encryption tool. Unless a client can use the correct WEP key, it cannot associate with an AP. The AP tests the client's knowledge of the